Good afternoon, fellow 8th grade science students. Today I'm coming to you with a game known as Mousetrap. Maybe some of you have never heard of it before, but it is a great family game that shows us the difference or helps us understand the couple topics that we've been talking about in the past couple of weeks. Last week we talked about changes in motion, how we change the motion of an object, what happens when they collide, I believe was our main focus last week. And this week we transition to Newton's third law. Last week we were pretty much talking about Newton's second law, which means that force and acceleration, the speed and the direction in which an object is moving, and the mass of the object in regards to how it is the amount of force that is needed to make it move. This week we're moving into Newton's third law. If you have any interest in rockets, collisions, I believe that is our question this week. When we talk about, last week was why do some objects require more force to move than others? And this week is what happens when two objects collide. So we are talking about Newton's third law. For every action, there's an opposite or equal reaction. So back to my game of Mousetrap. This would have been an activity that we would have conducted. I would have given you a bunch of different children's games that maybe some of you still find in your homes. Last week we did tug of war. And so obviously the more force that's being applied to either side is going to be victorious. And so that applies again to Newton's second law. This is a system, clearly a system. And so this is what you see on my screen is what is a system. So the basic things that you need to consider when you play this game or any other type of game that creates a force that creates it to work, and the amount of force that is applied. So you think about the parts, you think about how they are all put together, and obviously this took me, honestly, too much time to put together. And I had to look at YouTube. I couldn't remember. It's been so long since I've played it. So, but I got it, and I have gotten it to work. Cross your fingers that it works this time. So back to the parts. And then you have to understand it's going to require force. All I have is some metal marbles in the system. And the key here is you look down through these questions. Get this to scroll for you. There we go. We look at this page that I have here on the screen for you, and it says, what are the parts? How do you get the system to work? What do you do? And then just basically what are the guidelines and what are the rules and how do you make the system, this board game, how do you make it work? And like I said, this is a true testament of how we see Newton's laws work in regards to force. So if you haven't played, I have this wheel here that turns, but if I turn it, it's like it's half revolution. It makes my boot here, see it move. It's like a stop sign. It's resting on a stop sign. And it makes my boot swing up, miss the bucket. This is the bucket with the marble, and swing to the back like that. So it's very calculated. I'm just going to kind of go through the system. So this wheel spins, which is it's on a rubber band. So it's like a spring. It's going to move the stop sign back. It's going to move the boot. So there's a force hitting the boot. It's going to topple. Excuse me. It's going to topple. It's a lot like those big, huge water parks, and they have those big buckets, and the bucket fills with water, and then it starts to ding, and then it goes down this roof, and you get wet. It's a lot of fun. So force is from the boot that is applied. So for every action, kick, like kicking a ball, kicks the bucket, topples the marble. The marble should come down this step down and through the chute. Then it's going to hit this plastic. There's another marble on top here that is going to be pushed forward by the push of this marble hitting this stand, for the lack of a better word. It goes into this tub-shaped thing that has a hole in it. And then it makes our guy here flip, and this is raised a little bit. Then it hits this basket, and we have Mr. Mouse down here. I'll put him in your frame for you. And he captures. And that is kind of the objective of this game, is that you don't want your mouse to get caught underneath Mousetrap, right? Underneath the basket that's up here top of our system. Okay, like I said, cross your fingers. It takes some finesse, so to speak. So I'm gonna give my wheel a roll. I kind of help it a little bit. Oops, it just fell apart. See, it's not perfect. I'm going to, you can tell I'm applying some force. Again, and I'm going to kind of do it myself. So I make sure that the boot, failure. If not the first time, try again, right? Missed. You don't want to sit here and watch me do this all day. Okay, I put the marble into action. It's gonna come down here. Didn't give it enough force, did it? Okay, again, this has to come at a certain speed to make this one topple. So I'm gonna help it. Ta-da! Marvelous. All right, that is a very simple, almost elementary, keep it simple, elementary means of showing you how, for every action, there's an opposite or equal reaction. Newton's third law. Have an awesome week.